All right. So this is the assignment that we have for today. You should see it assigned in Discovery Education when you open up your Chromebooks, which should be closed. Yes.
You talk about the questions and stuff. I only just walk through it with you so I don't forget it.
Well, because first off, I don't want to have to basically tell you all the answers. That's not the point. And second of all, I want to get through it kind of quickly. If you need to go in and read, I do have the reading assigned. So this astronomy link will take you to the first page, and you should be able to find all the stuff that we're going to talk about. But I kind of want you to bank this in your memory and kind of pull the answers out of your memory, which is better for you on the test and on the quizzes when we actually have them. So the first one asks about the solar system in terms of the 4 terrestrial planets and the 4 gas planets. Write a short paragraph, and short is fine, that compares and contrasts the features that scientists have observed and their surface features. So what's the difference between the 4 inner planets and the 4 outer planets?
Gas giants and solids.
Yeah, the inner ones are small and rocky and hard and more dense. The outer ones are big and gaseous and less dense. And if you're talking about surface features, on the surface here, even on Earth, although Earth has dynamics which kind of wipe this away a little bit, the 4 inner planets, you see a lot of craters, and you have the hard surface, where on the 4 outer planets, we don't even really see the surface, not the hard surface. We see the clouds and the atmosphere, so we don't really know much about the surface. And in fact, hold on a second, if you scroll down, they kind of compare them in this chart, and they talk about the surface pressure. And for the outer ones, it's unknown because we've never even gotten to the surface of those planets. And by surface, they mean hard surface, not like the gas surface. Yes?
Is Jupiter colder than Earth?
Oh, yeah. They actually have that in the chart. So average surface temperature for Jupiter is 110 degrees negative Celsius, where Earth is 15 degrees Celsius on average. Yes?
Have we ever flown through one of the gas planets?
We crashed a satellite into Jupiter recently. Which one was it? I will look it up in a second. But we did crash one into it, but it didn't get very far before it broke up and we lost signal, because the atmosphere is so dense, and once you get down just a little bit, the pressure is so much. So we did fly it into it, but it didn't land or get anywhere very deep. Just kind of blew up. Yeah. But
lay on it?
No, because the gravity is going to pull you down into it. And with that spaceship, it wasn't like we were slowing down. And so it went very quickly into the surface, which, just like an asteroid in our atmosphere, which is way thinner than these atmospheres, it heats up and burns up. And so that's what happened to that satellite. I can't remember what the name of it was.
How big is the core compared to it?
We have guesses on that, and that was in on one of the other pages. I'll see if I can find it, but we think it's relatively small. We think they're mostly gas, and only at the very center.
So what's the
probably bigger than the Earth. Yeah, probably about that size. Only at the very center does it actually get enough pressure to become like a liquid. What was the next question? So the first one, compare and contrast the inner and outer planets. 2, now think about the solar system in terms of tectonic activity. What do scientists mean by the term tectonic activity? What does that mean?
Plates.
Tectonic plates, which in general, what means tectonic activity around here? When they move, what happens? Earthquakes, and then what's the other thing that happens? Volcanoes. So earthquakes and volcanoes. Name the 2 planets in the solar system that display tectonic activity. So what's one of them? Earth. Earth is one. Io's just a moon. It's not a planet, but that is a good one. What's the other planet that probably has tectonic activity? It's actually not Mars. Mars used to. So there's a big volcano on Mars, but it's not active. It's very old. Venus is the other one. Remember that Venus is very similar to Earth. They're kind of twin planets, even though they don't look like it anymore. And so Venus has active tectonics. They have lots and lots of volcanoes, which we didn't show in this class, but in my PowerPoint for dual credit geology, there's a picture of an active volcano in Venus. And so, yeah,
Always just erupting?
it's Earth and Venus that have tectonic activity.
If Venus and Earth is so much alike, why are they trying to what's called on Mars instead of Venus?
Because Venus, we used to be alike. Let me come over here so they can see. We used to be alike, but at some point we really diverged. And now Venus has a very thick atmosphere, which for us would be poisonous. And if you look down here, the pressure is too much. So the pressure at the surface is 92 bar, where here on Earth it's 1. So the atmosphere would crush us. It would be too poisonous, and it's way too hot. The surface temperature is like 464 degrees Celsius versus Earth. It was just 15 degrees Celsius.
Mars is only 0.01. It's like right next to ours.
Yeah, the surface pressure. Well, no, but that's the atmospheric pressure. So Mars has very little atmosphere, which is why that's really low.
What does that mean?
Like the atmosphere is blown away, so there's no air to breathe. Even if it were breathable, it wouldn't hurt us like poisonous. There's just not very much there. Yes.
Wait, how is Venus hotter than Mercury?
Because of the gas clouds, because Mercury doesn't have any atmosphere. So the side that's facing the sun is very, very hot, but the side that's not facing the sun is very, very cold, which is why it equals out to about 0, because it's above and below Celsius. And so half the planet's really hot, half the planet's really cold, and it just stays that way as it turns around. Whichever side is away from the sun is really cold. Where Venus has those, never mind, that's surface pressure. But still, it's a relatively lower average temperature. Venus is hot all the way around because that atmosphere holds the heat in. So yeah. But yeah, the tectonic planets, that's going to be Venus and Earth. You know the two things that display tectonic activity are earthquakes and volcanoes, and we've seen those on both of the planets. As you think about your reading and viewing of the videos in this course, which they have like so many videos, you'd spend hours just watching the videos from each section. Identify 3 conditions necessary for a planet to sustain life as we know it on this Earth. What are the 3 things we need to sustain life?
Water.
Air.
We need breathable air. We need water, but specifically what kind of water?
Clean.
Liquid water. It doesn't really have to be clean because there's lots of things that live in the dirty water.
Why is that to be liquid?
Because solid water in ice form just doesn't really support life. It's not available for intake in the same way that liquid water is. And so there's liquid water on the outer planets. Well, no, there's not liquid water. There's ice on the outer planets, but it's not habitable for life as far as we know it. And so, listen, we might find something different, but as far as we know right now here on Earth, it's got to have liquid water in order to survive. That is like one of the things you need. So we talked about atmosphere, we talked about liquid water, and then what's the third thing that we need? Well, food kind of goes along with the water, but that's not, I don't think that's really it. The temperature, your temperature's got to be good. And that kind of goes with the liquid water part, is if it's too hot, your water's going to evaporate into a gas. If it's too cold, your water's going to be ice. And so we might actually go into the reading real quick and verify what they're looking for. I'll do that in a second. I want to go through the questions first. But I might make an addendum to that once I look through the reading. So section 2, those are 3 pretty easy questions you can answer quickly. Section 2 gives you this chart and starts to ask you some questions about that. On the basis of the data table, identify planets which have surface temperatures suitable to sustain life. Pretty much it's just going to be Earth. Mars sometimes in some places does have a temperature that's sustainable for life. On average, it's way too low. And so we're going to say no there. And we know there's not life there.
But
and
if we put an atmosphere on there, we could live on there.
if you put an atmosphere, it could be very different. But it doesn't have an atmosphere. And if we go and we live there, we're going to have to live in bubbles. We're going to have to create our own safe environment. So pretty much it's just going to be Earth.
How would we make an atmosphere for Mars?
They've talked about that.
Blow a
So
bunch of stuff up and
you either bring big machines that insert a lot of the needed gases for an atmosphere, or what some people have proposed is there's ice at the poles, and if you drop nuclear bombs on the ice, it instantly vaporizes them and creates kind of an atmosphere. The problem with Mars, though, like I said, it no longer has tectonic activity. which means that its interior core isn't moving around like it should be, and so it's not produced a magnetic field. So even if you put an atmosphere on Mars, you have to have a magnetic field to protect it, or it's just going to blow away in the sun's radiation, which is why it doesn't have an atmosphere now. We know that it used to because the rocks are different than a planet that does not have an atmosphere. So it used to have an atmosphere, and then at some point in time, the sun's radiation and cosmic waves, not solar rays is what I meant, blew it away out into space. And so unless you build something to kind of protect that, like you make an artificial magnetic field,
Kickstart Mars.
it's just going to keep going. Not really. Well, maybe in the future with some science fiction technology, but we don't have anything like that now. That would be too crazy. So, which planets have the surface temperature suitable for life? It's pretty much Earth, but describe it a little bit. Give me a sentence. On the basis of the data table, identify planets which have average surface atmosphere pressures suitable to sustain life. Earth has 1 bar. Mercury at 0 bars isn't crazy bad. I mean, we could live there, not temperature wise, but atmosphere wise. If we brought our own little bubbles there, it wouldn't be too bad. Same thing with Mars, 0.00 or 0.01. If we bring our own little bubbles of air, we can live there. It's not going to kill us. Everything else, 92, and obviously these big gas giants are going to have way too much pressure. Even if we bring our own little bubbles, we would be crushed by the pressure. It's just way too much pressure for us to be able to handle. And so really, only these 3, I would say without technology, only Earth, obviously. But if you have good enough technology, you could also go to Mercury or Mars if you could deal with the temperatures and all the other issues. But pressure alone, probably just those 3. Number 6, explain how a planet's mass influences its capability to support life. If you have really big mass, what's going to be the problem there? What do these big planets have that will keep us from going down to the surface and exploring? Pressure. So it's the atmospheric pressure, but also what's another kind of pressure that we feel like right now?
Gravity?
Yes, the gravity is going to be too much. The gravitational pressure will literally like crush our bones. And so
So it'd be like, even if like nothing harmless on the way there, we couldn't even walk.
yeah, no, you couldn't even walk unless you had like a metallic exoskeleton. Remember when probably in an earlier age they talked about how much you would weigh on Mars and how much you weigh on the moon, and how the astronauts can like leap even though their suits are hundreds of pounds, and they jump up and kind of float a little bit and come back down. That's because the gravity's less. We can deal with that. Our bones are strong. But if the gravity's more, you weigh, like instead of weighing 150 pounds on Earth, you're going to weigh like 500, 600 pounds on a larger planet. Even though you're not that big, that's how much you weigh. And so your bones can't support that. It will literally snap your bones if you try to stand up. If you're laying down, your lungs won't be able to fill with air. Your diaphragm won't be able to push your chest up enough to fill your lungs with air. And so, yeah, the gravity is an issue. So that's what they're talking about there with the mass question. Surface atmosphere, mass influences its capability to support life. If there's too much mass, there's too much gravity, and life as we know it won't be able to survive. Maybe there's different life that we haven't figured out yet that could do it, but as we know it, not yet.
How many G's do you think you would like produce the gravity?
Oh, they've calculated that. I can look that up maybe. So give me a minute after we're done with this, and I'll look up some of that stuff. Do you have a question? No. What do you got?
How much gravity does Pluto have?
Pluto. Well, the gas giants are tough to say because at the surface, you're gonna have a whole bunch because they're so much bigger and there's so much more mass.
Like Pluto's a
Well, actually, huh? Pluto is actually rocky. Never mind. And Pluto is smaller.
That's what I was thinking. So like,
I'll have to look that up. I don't know off the top of my head, but I think Pluto is smaller than Mercury. Yeah. So it would be pretty low.
Smaller than that at the top left, right there.
Maybe like close to the size of the moon. So
Smaller than the moon.
it's smaller than the moon. So our moon has 1/6 of Earth's gravity. So Pluto's probably going to be like an 1/8, a 10th. Maybe something less like that. Yeah. All right, last question.
No gravity.
On the basis of the data table, identify planets which have masses that would be suitable to support life. So here's your mass: Earth, Mars. As far as just mass, Venus could. Mercury, it wouldn't be great. You'd be really light and you could move around really easily, but the mass itself wouldn't kill you on
How
Mercury.
fast do you think you would go on Mercury?
But everything else would be, well, that depends, because fast, like running, relies on you getting good traction. And so if you watch the guys in the moon videos, they're really light, but they're not fast because it's like these leaps. Like, you ever have, this is going to sound crazy, you ever have the dream where you're trying to run from something, but it feels like you're running through water, and it's just the most frustrating thing ever, and you're like, I gotta get away, and you just can't run fast at all. Yeah. Yeah, you're like, try to punch, but it's like, "Urgh." Yeah, and it's the weakest punch ever. That would be kind of like what you have, because you just don't have the gravity to give you enough connection to force yourself forward. Now, if we live on there for like 10, 20, 30 years, or someone grows up on that planet, they might be much better at running fast there. So you never know. But
do you think if somebody was to live on Mercury and just develop like a style of running on there, they'd be faster than on Earth?
maybe, yeah. Because you have less gravity, and so if you can translate that into forward motion, there's less impact every time you hit the ground, and you could probably get going pretty fast. Now, that being said, you trip and fall, you're gonna like tumble for like a mile maybe, and that might be bad. Did you have a question?
Or like, maybe like muscle memory might take over, and you might like imitate the running there on Earth. You think?
Yeah, and then you'd probably like fall a lot because you're trying to take big steps and gravity's pulling you down, and so you're not getting the right kind of gait.
You like put like a pole on the ground and like attach yourself to the pole and like ram like the pole between your
Yeah,
legs.
if you had something, yeah. So y'all need to design video games where you try to like run on Mercury or something. Okay, so those are the 7 questions. The first 3, I think you should be able to answer and give me a decent answer. The last 4 are all based off of this chart. So if you have any questions, please let me know. For the online folks, if you have questions, let me know. I hope this video helped you out a little bit. And send me an email if you have any questions or anything. Here. Does everybody want to say hi to the online people? Hello, online class. If you come back to school, you will have these people in your classroom.